In this video I will show you how to create a new experiment and add antibiogram images to that experiment in AntibiogramJ. So here we have the screen of AntibiogramJ. As you can see, it's empty. So we go to File, select New Experiment, and we provide a name, for instance, Experiment 1. Right? Okay, so here we have the experiment, it's empty. We haven't added yet any antibiogram. So we click this button to analyze an image and add it. So here we open this image, for instance. Here we are. And the first step consists in providing information about the bacterial isolate. So this is an Enterobacteria. The genus is Escherichia, and it's an E. coli. And the strain is this one. So we are. Then we have to crop the image to keep just the disc, the Petri disc in the image. So we have two options. We can use the automatic selection button. This will recognize the Petri disc. This can take some seconds. Okay, here we are. And once that we are happy with this selection, we can crop the image and we just see the plate. Another option consists in manually selecting the region to crop and then pressing the crop button. Now we go to the next step, where we can adjust the brightness and contrast of the image. There are two options. Using the auto adjust button, you can see that the brightness and the contrast is better now. We can also reset and adjust the brightness manually. Here you can play as much as you want. So we go to the next step, and in this step the antibiotic discs are detected. So you can see here that the detection is not perfect in some of them, so we can modify them. We can also add new ones. For instance, we select this region and press the add button, and a new disc is selected. We can remove it, just pressing on the button and so on. Now in the next step we have to fix the size in millimeters of the diameters of one of these discs. This is used to calibrate the image, because you can use images of different types and capture with different lenses, so it's necessary this calibration step. You press the next button, and here you can see that the next step, the antibiotic discs are read, and you can see here the antibiotic discs that have been read. So in some cases you might need to modify them, or at the beginning when you are started using this program, you have to manually introduce the value, because it's a learning system. So we will go to change button, and well, you have here the families and the names of the antibiotics. Okay, so you can change. We press next. In some cases there are some several options for the breakpoint, so we need to select the correct option, and in the next step the allos are detected. This is a process that is conducted in parallel, and here we are. So we have here the information for each inhibition zone. So the yellow region indicates the inhibition zone that it has been detected, and the red circle indicates the resistance size. Okay, so the limit of the resistance size. So we have to check. Well, here you can see also the category and introduce some values like in the microcolony and so on. So we can check all of them. So here you can see that there is a blue region that indicates the limit of the resistance of the susceptibility. Okay, and well, you can change this value, you can increase the size and so on. So in this case it's resistant. in this case is susceptible, so on, so you can try the different ones. In this we can set that there is microcolonies, and so on. And once that all this is checked, we can annotate the image. We can use the same configuration for all of them, put the category, the diameter, and increase the text size, or use the radius, change the alignment, and so on. Change the color, and we can change individually. So we can select this as blue, and so on. And when we press finish, the experiment, the antibiogram is added to the main window. So you here see a summary of the experiments, and if you click with the different antibiotics, and if you click on the concrete antibiogram, you can see the tab with that information.